This is a technique, or these are group of techniques. In fact, there are a couple of techniques inside factor analysis. So these are group of techniques used to reduce the number of variables in our data set. And why do we need to reduce the number of variables? Often we are given a large number of variables for the modeling purpose, and we cannot of course use all the variables in our model. Hence we always want the best in class variables out of a whole bunch of variables, and factor analysis is one way in which we can reduce the number of variables. There are of course other ways, but factor analysis is one of the way. What happens is that when we are given a large number of variables for modeling, we often find that some of the variables are highly correlated, or there is redundancy in the data. Variables are quite related. Some the same variable is being measured twice, in a very similar fashion, but they are essentially giving us the same information. For example, you want to know somebody's ability in doing quantitative analysis. So how do you know somebody is able to do that or not? Okay, so look at the marks he has scored in mathematics, and you will know whether he's good in quantitative, whether his quantitative aptitude is good enough or not. Again, look at his marks in statistics or in computer science or in physics. So these all are quantitative subjects. So the most likely you will find that somebody who has scored good in physics will also score good in mathematics, computer science, statistics, because all the variables, all the four variables measure pretty much the same thing: the quantitative ability of a student. So naturally these variables will be related. We can we can say that there is a redundancy in the data set. So most of the times you will find that the variables you were given are redundant in nature. To get rid of this redundancy, we use factor analysis. So how do we get rid of the redundancy? Factor analysis reduces a set of variables, highly correlated variables, into a small number of latent factors. So what these latent factors are? Well, the latent factors are we call them unobservable variables. They are also a variable, but we assume that these latent factors are able to explain each and every correlated variables. Say for example, there are 5 correlated variables. They are correlated among themselves. Okay, and we say that okay, there are 2 factors which explain all these 5 variables. So instead of taking the 5 variables, we can take the 2 factors. Of course, we will study how to come up with these factors. It's not that easy. It's very difficult to understand, and a complex procedure is involved in order to find the 2 latent factors out of these 5 correlated variables. Okay, but only thing is that make sure that your variables are related in some way. They have a very high correlation among them. That's a precondition. Well, to give an example and to understand it better, well, our analysis for this particular illustration, I have taken it as how do we measure the academic ability of a student? Well, we can measure it basically by 2 means. Look at his quantitative ability and look at his verbal ability. Right? If you write the GRE, we are also measured in these 2 aspects, right? One is a quantitative paper on quantitative things, and the other one is a paper uh, on the verbal side, right? We are judged in both aspects. Now quantitative ability can be judged by couple of couple of indicators, a couple of variables: mathematics score, computer programming score, physics score, statistics score, right? Now, verbal ability score, verbal ability of a student can be measured by the score in the English or the verbal reasoning. That's how we measure the verbal ability. Now, say for example, we have been given this five variables, and we can be very sure that some of these variables are correlated. We have five variables: mathematics score, programming score, physics, English score, verbal reasoning score. These five variables are correlated among themselves in some way. Okay, mathematics score is correlated to computer programming score, and mathematics score again correlated with physics, and they're all correlated among themselves. But very unlikely mathematics score will be correlated to English, right? It may not be correlated. Okay, but English score will be correlated with verbal reasoning score. Okay, so if we are given these five variables, we need to find out which all are correlated among themselves and which all can be grouped together in a one factor. Okay, so if we are given five variables, we can get down to two factor or two latent variables. Okay, so quantitative ability and verbal ability, we can call it as a latent variable or a latent factor, whatever, factors are nothing but variable at the end of the day. So instead of using the five variables, we can just use the two latent variable in our model. We can only have quantitative ability and verbal ability. The question arises here is that how do we know, how do we know that variables can be, which all variables can be grouped together, and how do we group them, how do we come up with numbers? That's a very important thing, and it's very as I said in the beginning, it's not a very simple thing to understand. But one thing is clear from here is that factor analysis is a technique in which we group variables, similar variable, into different buckets. Okay, so instead of using the variables, we just use the buckets or the factors in place, right? That's the way we can reduce a number of variables. Say for example, we have 100 variables, we can get down to 8 or 10 or 15 factors, and then instead of using the 100 variables, we will be instead using the 10 factor, 10, 12, whatever it is. Of course, there are questions like who do choose the combination of variable, whether we choose the combination of variable, how do we group the variable, whether it's the analyst who does the selection, or it's the computer algorithm. Okay, we'll see. Okay, as I said in the beginning that factor analysis is one way of exploring pattern in your data, right? Nowadays we have the concept of having very big data set or big, quite big data sets given to us, having lot of variables, and we don't know how to use them, and of course we cannot have this just all the variables in our model. Factor analysis is one way in which we can explore the data or explore pattern in the data to know which all variables are similar, and we can just drop some of them or probably group some of them into factors, all that thing. Okay, as I said, we have been given the 6 7 variables. Do I need to choose them, or do somebody else, or the algorithm will tell me that which all variables out of these 6 variables on your screen you can see are similar? Well, there are two ways of doing it. You yourself can do it. If you are very good at knowing, you know the pattern in the variable. You know the pattern in the variable. Okay, then you don't need to ask the algorithm in your software to do it for you. But if you have no idea about the variables, you have no idea how they are related, you don't come from the business, or you have no knowledge about the domain, or something you want to explore, something, probably you are quite an expert, you are a good expert in that area, but you still, want to explore how the data or how the variables are related. We can use the mathematical algorithm to find it out. Okay, and that's the two ways, like two ways we have in which we can select the similar variables and group it together. There are two ways of factor analysis, as I said. The first way, in which we only select the variables, we call it as confirmatory factor analysis. The other way is wherein the algorithm choose variables for us or finds out a pattern for us, is known as exploratory factor analysis. Okay, as I said, there are two different factor analysis available to us: exploratory factor analysis and confirmatory factor analysis. So, what is exploratory factor analysis? Well, by using exploratory factor analysis, we explore the pattern among variables. We do not have any prior hypothesis to start with. We do not know which all variables are related. What is the pattern that exists in the data? We have no clue. Okay, we use mathematical algorithm to find it out. In confirmatory factor analysis, we only specify the model, or we only specify that this pattern exists. Well, the question that may be coming in our mind is that how do we know that? How do we know which variables are similar? Well, sometimes this is very popular in the psychometry and behavioral analysis, behavioral analytical modeling, wherein you have some idea from the previous studies. Okay, because somebody might have done it previously and some idea is already there or some knowledge is there. You have literature to follow. So, and somebody who is an expert in a particular field, say for example, I'm a businessman, I have been doing the same business for many years, so I have clear understanding about the variables. I know what exactly the pattern that exists. Okay, I don't trust the algorithm or the data. I only trust my understanding about the variable. So that is more like qualitative analysis. That's the way I group my variable. Okay, just by using my understanding about the data. But mostly we use both. Okay, it they are used in conjunction with each other because both the analysis are actually very useful. How do we know that both can be used? Well, in exploratory factor analysis, in short we call it as EFA. Using EFA we can get to know the pattern. Okay, we may be having some idea about the data, but we may find out some more information or some more pattern which we didn't know from the literature or from our existing knowledge, and then we can combine the both, the knowledge that we have got by using the algorithm in the data and the knowledge we already have about the data. We combine them both and then we use the confirmatory factor analysis to make sure that our understanding, when we combine two kind of knowledge, is actually good enough for this data, and it's a good model, or as the word say, confirmatory, we confirmatory factor analysis in short is known as CFA. So EFA and CFA, uh, you'll be demonstrated in an example in the in a video wherein I'll use both EFA and CFA, um, and do analysis using SAS. Well, the mathematics is not very simple, but it requires a lot of interest to go into the detail. But to keep it very simple, we assume that each variable, correlated variable, is a function of couple of factors. Okay, we have four variables: v1, v2, v3, v4. Okay, let's assume we have four variables. v1, v2 are correlated, and v3, v4 are correlated. v1 is a linear combination of f1 and f2. So is v2. So is v3 and v4. But if you can see, v1 and v2 are explained by factor 1. Okay, f1, because factor 1. So v1 is a linear combination of f1 and f2. Okay, it's like a regression equation. Okay, where the a1 is significant but b1 is not significant, or very less significant. Okay, so we say that v1 is being explained by factor 1. Similarly, v2, the coefficient b2 is insignificant and a2 is actually significant. So we say that variable v2 is being explained by factor 1. Okay, and that's how we know that v1 and v2 are similar and they can be put together, and we can just have one factor 1. So in place of v1 and v2, we will use only the Latin variable factor 1 or f1. Okay, how do we estimate a1, a2, f1, f2, b1, b2? Well, we estimate the factor or the values of the factor through the maximum likelihood estimation. To know more about the maximum likelihood estimation, please watch the video on maximum likelihood estimation. Similarly, a v3 is a linear combination of f1 and f2 again, but you can see the coefficient for f2 is significant here, as I have marked, but coefficient of f1 is very less significant or not at all significant. Similarly, v4 is a linear combination of f1 and f2. The coefficient for f2 is significant, whereas coefficient for f1 is very less significant or not at all significant. And that's the way we group v3 and v2 and come up with the latent factor f2. Some of the uses of factor analysis, as I've already said, variable reduction is one use. When you have large collection of correlated variable, you can use factor analysis to come up with a very few latent factors. Pattern among variable. Okay, sometimes we need to know which all variables are very related to each other. So we can use it for exploratory data analysis before doing any modeling work. You are doing multiple regression, logistic regression, any kind of regression you are doing. It's good to run a factor analysis to know which all variables are correlated. Okay, so it helps in knowing your data or visualize your data or explore your data. When you have a lot of knowledge by exploring the data, you can build a model better. So it may not be directly used in the modeling, but yes, it helps in the modeling. Okay, and then the final use is the confirmatory modeling. Well, the confirmatory modeling is not a very popular modeling in the industry, but it's the type of modeling I'll not discuss in detail. um, there are different kind of confirmatory modeling available. One of the confirmatory model that I use is the structural equation modeling, wherein we define a model and then use factor analysis to confirm whether the defined model or the specified model is correct or not. You can explore on this more. I will not go into the detail. Certain things to consider when you are doing factor analysis. Of course, I'll be having another video on doing factor analysis using SAS, wherein all the things will be discussed in detail, and that will be a hands-on session, and will be you'll be able to make sense of the things better. Make sure the variables are related. So whenever you are giving variables to the algorithm or inputting variables, the input variables should be related among themselves. If you know for sure that they are not related, there is no point in doing a factor analysis. Okay, you cannot have a completely different variables together and then you do some analysis on them. It's difficult. It's not recommended. You're simply wasting your time. You should have sufficient number of variables. Okay, so you cannot have a factor that is related to just one variable or a two variable. Okay, so that's not a very having a factor, if one factor for one variable is unacceptable. Okay, at least three variables should be related among themselves or correlated among themselves to, so that at least one factor can be made out of the three variables. Okay, make sure you have large number of observations. Okay, because correlation is very unstable in case we have less number of observation. So more the number of observation we have, the better and the factor analysis can be done. One of the criteria, which is of course not a very strict criteria, is that variable should be multivariate normal. Well, what is multivariate normal? I'll have a video on multivariate normality, but to put it in this way, multivariate normal is the way in which we all the variables you have used should be normally distributed. Multivariate means more than one variable, normal be normal distribution. So more than one variable normally distributed. When all your variables are normally distributed, naturally the entire data set is multivariate normal. Okay, but some researcher they say that the violation is okay. If it is there is a slight violation, then also it's okay. You can still use factor analysis. But of course, don't use purely categorical area variables or dummy variables in factor analysis. Make sure that it should be continuous. Okay, or there should be some sort of a continuity in your data. How is it different from principal component analysis? Well, functionally they are same. Okay, we use PCA, or principal component analysis, and factor analysis for variable reduction and data exploration. So the uses are same, but the underlying assumption or the mathematics behind them are very different. Okay, there is a lot of difference between the two techniques. The details, of course, is covered in the PCA video. So once you have watched the video on principal component analysis, that's when at the end I have discussed the basic differences in terms of the mathematical estimation between exploratory factor analysis and the principal component analysis. Thank you. In this video, I'll discuss about how to perform exploratory factor analysis in SAS. The confirmatory factor analysis will be covered in a separate session. What are the things that I am going to cover in this session? First, I'll do a correlation check of the variables. I'll also talk about how to use a proc factor for doing factor analysis, and then also I'll also cover the options available with proc factor in doing factor analysis. Make sure you have gone through my video on factor analysis theory. The name of the video is factor analysis, wherein I have covered the theory on factor analysis before going to this video. To illustrate this particular topic, I'm going to use a data set. Let me show you the data set. The data set has information on the school students. It's about the performance of the students in class. What are the variables available to us? We have mother education, father's education, family income, score in English, mathematics, science, social science, natural science, and vocabulary. Okay. After factor analysis, I am going to build a model based on the performance of the student. I am going to categorize student into good and bad. Okay, with some criteria I have categorized with student type 0 and 1. 1 is good and 0 is bad. But student type variable, which is a binary variable, is not going to be used for factor analysis. Okay, so that is going to be used in the future regression model. That's the reason why I have this variable in my data set, but this variable is not going to be used uh, for factor analysis. Okay, what is our objective? Well, the objective is that when we will do a regression model, I'm going to do a logistic regression model. Once the factor analysis, I have the factors in place, I'll regress student types with all the other variables, right? So that's my regression equation is going to be. How many independent variables I have? From mother education to vocabulary, I have 8 independent variables, and student type is my dependent variable. Okay. Now we have 8 independent variable, and there seems to be some kind of a redundancy in the data. So instead of using 8 independent variable, we can to get down to a very few number of factors. The objective of this session is to how to reduce a number of variables. We have 8 variables here to a very few number of factors, and then use these factors for the regression model. Got it? First thing we will do is to see the correlation. We will do the correlation check first. I'm using all the variable except student underscore type. As I said, that particular variable is not going to be used for factor analysis. Let us go to okay. You can see that there is high correlation among variables. High correlation between vocabulary skills and English. Makes sense. High correlation between vocabulary ability and then social science. Hence, we can conclude that there is some level of redundancy in our data. And when we have redundancy in the data, we need to use factor analysis to come up with a few number of factors out of this large number of variable. We don't have a large number of variable, but we can of course reduce the number of variables from 8 to a very few number of factors. Proc factor is the SAS proc that is used for factor analysis. Proc factor data, name of the data, and then in var you mention all the variables that you want to use in factor analysis. This is the simple form of proc factor syntax. There are options available. We will use the options later. Let us run the very simple version of proc factor. you will have so many things in the output. Not everything will be covered in this session. The important things will only be covered. You can see a message that two factors will be retained. So proc factor says that out of these 8 variables, we can you can make these 8 variables into two factors. Okay, we can group the 8 variables in such a way that we will only have two factors in place. We never asked SAS to group them into two factors. It's SAS by certain criteria. Well, the criteria is Bayesian criteria. You can read the SAS manual to get to know more about this criteria. Using that criteria, SAS tells us that two factors will be retained. Okay. Let's go to the box factor pattern. You can see there is factor 1 and factor 2. Automatically we have two factors in place directly given from the algorithm. Now how do we know that? If you remember my session on factor analysis, what I told is that each and every variable is a linear combination of the factors. Okay. Let's take this variable mother's education. So mother's education is a linear combination of factor 1 and factor 2. The coefficient, okay, this is the estimated coefficient. The estimated coefficient for factor 1 is 0.41 and that with factor 2 is 0.69. Similarly, for father education, the estimate, the coefficient of factor 1 is 0.5 and the estimated coefficient for factor 2 is 0.69. Okay, we can write it down like this: mother's education equal to 0.41 factor 1 plus 0.6 factor 2. Similarly, we can write such equation, this type of equations, for all the variables that we have used. Now remember one thing. If you remember what I talked, what I taught in the factor analysis video, the theory part I'm talking about. Out of the two coefficients, look at the one which is having a higher value. Okay. Usually one of the coefficient will be significantly higher than the other. This coefficient for factor 2 is significantly higher than coefficient for factor 1, right? So 0.6 is greater than 0.4. Okay. Hence, mother education is explained more by factor 2 and less by factor 1. Got it? Hence, factor 2 is contributing more towards explaining variation in mother's education. So factor 2 is the latent factor associated with mother education. Now let us go back to the result and see where factor 1 is contributing more. If you see English, the coefficient for English score is 0.77 for factor 1 and minus 0.23 for factor 2. Hence, factor 1 is contributing more to the English score than factor 2. Similarly, mathematics. Factor 1 is 0.77 and factor 2 is 0.17. The coefficient for factor 1 is significantly higher than coefficient for factor 2. Hence, factor 1 is contributing more to the mathematics score. Okay. So there is a trick here, how to club variables, right? We have got factor 1 and factor 2. So how to club variables into separate factor. Okay. Wherever you have higher coefficient, just mark it. First variable mother education, I'll mark this one. Second variable father education, factor 2 coefficient is higher, again I'll mark the second one. And then family income 0.6 against 0.4 for factor 1. So coefficient for factor 2 is higher. Hence, and no other cases, right? In no other cases you have factor 2 having higher coefficient. So only first three variables are the ones where the coefficient for factor 2 is higher than coefficient for factor 1. Hence, the first three variables, mother education, father education and family income, can be clubbed together. Okay, so that come under the factor 2. Okay, in the last 5 variables, in all the cases, the coefficient for factor 1, you can see it, is higher than the coefficient for factor 2. Hence, we can club these 5 variables into factor 1. Okay, so that's how we group the variables. Factor analysis is all about grouping variables into one single factor, right? Okay. Remember, this is exploratory factor analysis, so we have no clue, no hypothesis to start with. We do not have any knowledge or very little knowledge about how the variables actually behave, or if there is any pattern, if at all there is any pattern among the variables that we have used. Okay, the SAS algorithms suggest us that we should be taking only 2 factors, but we have the option of selecting the number of factors. How do we do that? We can use the n factor criteria. Okay, so when we use the n factor option, we can mention there how many factors do we want to be there in the result. Okay, if we want to enforce it, if we don't want to enforce it, we just want to explore it, we can just let the algorithm to find it out for us. Okay, that's about exploration. I told, right, proc factor is used for data exploration purpose. So we start with no option, then we go on with options, and then keep changing the options to see if there is more pattern coming out from the results. Okay, let me give 3. Let me see what happens if I ask SAS to give me 3 factor instead of just 2. Let me see the factor patterns. You can see in the output there are 3 factors. Remember the way we group the variables. I talked about how to group variables, right? Now, when you have 3 factors, look at the coefficient which is the highest among all the factors, all 3 coefficient of 3 factors. For the first variable, it's factor 2 coefficient. Second variable, again, it's the factor 2. Similarly, in the third variable also, it's the factor 2. Okay, and then I don't see any valuable thing happening by enforcing 3 factor. The reason is because most of the pattern in the data is being explained by factor 1 and factor 2. Factor 3 is useless because except natural science, where not even natural science, yeah, I don't see even any place there is no variable where the coefficient of factor 3 is the highest among all three coefficients, right? Can you see? Yeah, I can't see that is there anywhere. So factor 3 doesn't add much of value to our analysis, right? So we can try it out, like we can keep increasing the number of factors and see what is happening. Okay, that is the way we do the analysis. As I told in the very beginning itself, that we don't go with any hypothesis, any knowledge, we just keep on exploring. So number of factor is 2. We could see that if we have 2 factor, that is enough, that explains our data set. The next thing that uh, we will study is how to plot a scree plot. To plot a scree plot, we use the option scree, SCREE. Let me run this. Well, what is scree plot? Well, it's nothing but it's a plot of the eigenvalues, and then this particular plot is used to find out the number of factors that should be retained. SAS suggests us that we should be using 2 factors, but we are not sure of it. I mean, because it's an algorithm at the end of the day. How do we select the number of factors to be retained? Look at this plot. Look at this plot. It keep decreasing, then it become flat, right? So there is an elbow-like structure. There is an elbow-like structure of this plot. Wherever we see the elbow, after the second eigenvalue, you can see that all the other eigenvalues are lying on more or less on the same line, right? The elbow-like structure is there at the second eigenvalue, and that is the way you select the number of factors to be retained. Okay, so we will return only 2 factors. Now, had it been the case where if this third eigenvalue, right, it would have been somewhere here, and the elbow-like structure would have been there at this eigenvalue, then we would have retained 3 factor instead of 2. But here it's there with the eigenvalue 2, hence we will keep only 2 factors. That is the use of scree plot. The next thing that we will study is about rotation, or factor rotation. Let's go back and see the factor pattern. There are 2 factors in place. Factor pattern gives us the coefficient that is estimated by using the estimation algorithm, and we find out that which variable is related to which factor, right? We group variables based on the factor loadings. We call it actually factor loading. Instead of coefficient, we actually call it factor loading. Rotation is a method using which we can discriminate between the factor loadings better. So what do you mean by that? Well, the factor loading for the variable father's education is 0.5 for factor 1 and 0.6 for factor 2. There is not much of a difference between them. Rotation us rotation helps us discriminating the factor loading. That means making it the distance between the factor loading for one factor and the other factor, making it maximum. Okay, so that it can be clearly distinguishable. Okay, what it essentially does inside the algorithm is that it orthogonalize the data set, orthogonalize the factor scores. Okay, what is orthogonalizing? That means it makes sure that there is a 90-degree or the two data sets are perpendicular to each other and not very correlated to each other, and ensuring that the factor loadings are entirely different and there is a distance maintained between them. Let us use it, it will be more clear. We use the option rotate equal to, well, there are several types of rotations available based on the fact that whether we want correlation between factor loadings or not factor loading, factor scores or not. Okay, so before rotation, let me tell you how to get factor scores. Right, when we combine variables, we need to get factor score, right, actual number. Okay, because if you study that first and then go to rotation, it will be easier to understand because things are confusing sometimes. We get it by using the out option. I'll save the factor scores along with my input variables in another data set. I am naming it as students1. You can name anything. Let me go to students1. You can see the last two columns, factor 1 and factor 2. You have the values for each and every set of observations. So that is nothing but a combination of several variables together to come up with factor scores. Factor 1 and factor 2 are the final variables we have from a whole set of variables. Only these two variables will be used for further analysis. Okay, we call them factor scores. Now let's go to the code and we will use rotation on them. Rotate. For rotation, I use the option rotate. There are basically two types of rotations available. Okay, one type of rotation, let me write it, is orthogonal. The other one is oblique. If we want our factor scores to be totally uncorrelated, remember the problem from which we started. We started from high correlation data, right? So we don't want high correlation in our factor. We went into factor analysis just because there was a presence of high correlation in my data. So we don't want any correlation among the factor scores. Okay, no correlation between factor scores. That's one of the way of handling it. Sometimes it's very impractical to impose this condition. Having no correlation between two variables is very impractical, very unrealistic. And sometimes in a modeling setup, we want some correlation, some practical correlation between these two factor scores. Okay, in such scenarios we use oblique rotation. Some correlation exists between the factor scores. So that's another type of rotation known as oblique rotation. I'll discuss only about orthogonal rotations. That's the most popular one. We don't go into the strictness criteria. Most of the times orthogonal rotation is used. For orthogonal rotation, we need to use rotate option. Rotate equal to vary max. If you want to use oblique rotation, just mention pro max. Okay, rotate equal to pro max. Promax. If you are using vary max, it's going to rotate in orthogonal fashion. Let me run it. Let me go to the factor patterns. Yes. When you mention the rotation option, you will get two factor patterns. The first one is the unrotated ones, and the second one is the rotated one. Okay, this is the first one. The first factor pattern in your output, in your result, is unrotated one, 0.4, 0.6. Remember these coefficients, the factor loadings, and let's go to the rotated one. Rotation method varimax, from where the rotation output is there. Now look at the factor loadings. In the unrotated output, the difference between the factor loadings for mother education was very little, right? 0.6 and 0.4. Look at here, 0.4 and 0.08. There is a, it's clearly seen that factor 2 is the one which is more related to mother's education. Right. Similarly, second variable, father's education. Clearly it is seen. There is no confusion at all. There is a distance between the factor loadings. Very high distance between the factor loadings for father's education. Similarly, for all the variables you can see. Okay. Again, I'll repeat how to group the variables into factor. Compare the factor loadings and then mark it. The best thing I do is that I take it to Excel and then I mark it in YOLO or something. Okay, you just highlight it and you'll get to know. And for mother's education, second factor, father education, compare the two loadings. The one which is higher, again you just mark it. First three variables are associated with factor 2. We group them and call them factor 2. The next 5 variables where the factor loading for factor 1 is higher than the factor loading for factor 2, I group them in one particular factor and we call them as factor 1. The next thing we will learn is how do we interpret these factors, because if we use factor 1 and factor 2 in the model, nobody is going to understand what a factor 1 is and what a factor 2 is. So how do we give a name that is understood by the by everyone? Like if we are going to explain this model to somebody else, we need to give a name to factor 1 and factor 2. Well, mother education, father education and family income show or indicate the family status of a child, whether he has come from a good family background or not, whether your parents are educated and having higher income or not. So that's about the family background or family status. So instead of calling factor 1, we can just rename it as family background factor. Family background factor. So that's our new name. That's the new name of our factor 1. And that is easy to understand, right? The next factor is factor 2. It has 5 variables, right? English, mathematics, social science, natural science and vocabulary. Well, we can call it as academic. What do we call it as? Quantitative and verbal ability. We have clubbed them together. Of course, we can make it two separate factors. I tried with three factors. I was thinking maybe we can have a factor for quantitative scores and then verbal score, but they have been clubbed together in factor 2. So we can call it as verbal and quantitative ability of the student. We can just use the rename statement in the data statement, like data students 1 rename factor 1 is um, family background, factor 2 is quant and verbal ability. Okay, the further analysis that we will be doing on this on this uh, factors is to model for whether a student is a good student or a bad student. As I have already shown you, the dependent variable is student type, which is a dichotomous one, so we'll be using proc logistic, right? Student type is my dependent variable. Instead of using 8 variables now, I'll be using only the two factors: family background factor and then the quant and verbal ability of the student. It's a simpler model having fewer number of variables and easy to explain to someone. We can of course explore more, make the factor better and more understandable. Okay, we can explore more and more about it to make the model easy to understand. That's how we perform factor analysis. To summarize, we start with correlation. We check for correlation first, and then if we find high correlation, we go in for factor analysis. In factor analysis, we use so many variables and then come up with a few number of factors. We can save the factor score in a different data set and use the factor score for further analysis. We use rotation to make sure that the factor loadings are very clear and it's easy for us to segregate between two different factors, which variable is related to which factor. And then we use scree plot to know the number of factors that is to be retained. The factor scores are finally used in the regression modeling or whatever kind of analysis that we are going to do with this data set. That's how we perform regression factor analysis. Thank you.